Hi, in this video we are going to talk about multi-dimensional arrays in Java. Let's take a look at this example. Here we have created a 2D array. We have used two square brackets and we have initialized this 2D array with elements as 1, 2, 3, 4, 5, 6. Now if we wish to traverse this array, we use arr.length to find how many rows this array has. Then we use arri.length to find how many columns individual rows have. So this loop is going to run 2 times because there are 2 rows, and this loop is going to run 3 times for every row because every row has 3 items. And inside this loop we have print statement, so we are going to get the output as 1, 2, 3, 4, 5, 6. This program, if you take a closer look at it, it looks different from C++ program or C++ style of creating multi-dimensional arrays. Here we have actually an array of objects. This 2-dimensional array is actually array of 2 array objects. And these individual objects are arrays and they have 3 elements. We find out how many total objects we have using array.length, which we call row, and then we traverse individual array objects by using their lengths. So we can have different number of elements also in individual objects. For example, if I change this program and if I write here 8, 9, then this program will work fine even if we have 5 elements in the first row and 3 elements in the second row. And this program is going to print 1, 2, 3, 8, 9, 4, 5, 6. This is what we are going to see on the screen. And how does this work? Since we have array of arrays, it is not mandatory that all these elements are stored at contiguous locations. So this is how the structure of a typical 2D array in Java is. You have an array of objects. Say there is an array of size m cross n. Then you will have m array objects. And these individual objects will have reference to objects which are arrays and of size n. So this last index is n-1, this is last index is n-1 and -1. And these sizes can be different also. This can be n1 -1, n2 -1 or n3 -1 because they are not at contiguous location. They may not be at contiguous location. So this is how Java stores multi-dimensional arrays or a typical 2D array, which is different from C++. In C++, when you create a 2D array of size m cross n, a contiguous block of m cross n memory is allocated and everything is stored at contiguous location. But in Java, it's not like this. In Java, if you want m cross n elements to be stored at contiguous location, you want to ensure this thing, then you will have to create one-dimensional array of size m cross n. Let's now see the second point. If we are coming from C++ programming world, we have habit of writing dimensions with the array name. Java does not allow this kind of dimension specification when you're creating arrays. You can either initialize the array this way so that Java compiler can automatically figure out what are the dimensions. It automatically figures out that there are 2 rows and the first row has 5 elements and the second row has 3 elements. And then there is a other way. Here is the other way to create arrays. I've created a 2D array of size 2 cross 3. I've passed these variables m and n when specifying the dimensions of this array. So this creates a 2D array of size m cross n in memory, and the structure of this array is like this. They are not at contiguous locations. They are in this form. There is an array of objects and these individual objects are arrays and all these objects are of size n and n, right? Now we are traversing the array, and since arrays are objects, they are automatically initialized as 0 if we do not specify any value or we do not assign any value to these individual elements. So when we run this program, we get the output as 0. If we wish to assign some value to them, say for example, if I want to assign something to every array element, I can assign this here, array ij equal to 10. So now I'll have to use curly brackets here inside this because I have 2 statements now. So once I assign the values 10 to every element, I'll get the output as 10, 10, 10, 6 times. So I've simply inserted this statement in the previous program and I have added curly brackets. When we do this, we are going to get 10 6 times because this time we have assigned the values to individual array elements. Here is one more modified program that prints content of 2D array in tabular form. I mainly added this new line statement inside this loop, right? So once you print a row, you print a new line. So first row is printed, then new line is added, then the second row is printed. This way we print the 2D array in tabular form. Let us now take a look at this program. We have created an array of m rows. We have not specified the number of columns in individual rows. So we can create jagged arrays of user specified sizes. Now user is free to choose size for individual rows. Now in this program, I've created the first row of size 1, the second row of size 2 and third row is of size 3. We have 3 rows in total. And after that, we are simply traversing through the individual rows after creating the individual rows and we are assigning the value to I. So the first row gets the value 0, the second row gets all values as 1 and third row gets all values as 2. You can put any values according to the software requirements. This is just a program to demonstrate how you can create jagged arrays, how you can create individual rows of different user specified sizes and how you can assign values to them. Here is pictorial representation of this program. This is what our array looks like. First row has only one element and the value of this element is 0. The second row has 2 elements and the values in this row are 1, 1. The third row has 3 elements and the values in this row are all 2. So now please pause this video and try to guess the output of this program. It must be very easy. We are going to get 0, then we are going to get 1, 1, then we are going to get 2, 2. Right? That's what we get as an output of this program. In this video, we have talked about 2D arrays, different ways of creating them. We have also talked about jagged arrays. A 2D array is called jagged array if all the rows are of not same sizes.